All right, so here I'm going to work through the nearpod activity so you guys can see how it should look if you were absent or if you just need to go back and watch for notes. Graph f of x, okay, equals negative x minus 2 squared plus 3, and g of x equals negative 1. And then it says, then solve the equation. So this is vertex form, all right? So I'm going to plot some points here. Okay, I'm going to start with the vertex. So the vertex is at 2, 3. I come over here, I put a dot at 2, 3. A is negative 1, so I'm going to go over 1, down 1, over 1, down 3, over 1, down 5, and then use the property of symmetry to get the rest of the points, and then draw my curve. Oops. Start that over again. There we go. And then graph y, g of x equals negative 1, which is just a horizontal line. Just change colors here so we can see it a little bit different. Okay, and so we know that these two functions are the same, they're equal when they cross. And so if you look over here when it says solve the equation, so negative, right, x minus 2 squared plus 3 equals negative 1. Notice that's just f of x. Okay, that's f of x equals g of x. And so we could use the graph to solve this. And so, which means we could use the graph to solve any quadratic. All right, we just graph the left side of the equation, we graph the right side of the equation. So they're the same when x equals 0 and 1, 2, 3, 4, and 4. All right, so x equals 0 and x equals 4 is when they are both at negative 1. All right, next slide. Okay, it's use the graphing calculator to confirm your answer. So if I'm typing in that the equations, so f of x was negative x minus 2 squared plus 3, and then g of x was negative 1. So again, we could definitely confirm that those were the answers 0 and 4. Okay, so now we have x squared minus 4x plus 2 is f of x, g of x equals 7. So now to graph, okay, so to graph this one, I've got to use negative b over 2a. All right, so I do all my work over here. So it'll be x equals, so let me change my font to a little bit skinnier. Okay, so x equals 4 over 2, which is just 2. And I'll plug that in. So y is going to equal, or f of x is going to equal 2 squared minus 4 times 2 plus 2. So y equals 4 minus 8 plus 2. So negative 4 plus 2 is negative 2. So my vertex is 2 comma negative 2. I plot those points. And then here my a is 1, positive 1. So over 1, up 1, over 1, up 3, over 1, up 5. Use symmetry to plot the rest. And draw your curve. Now we want to know, when does that equal 7? So 1, 2, 3, 4, 5, 6, 7. So I draw a horizontal line at 7. And we want to know, when do those cross? So they cross when x equals -1 and when x equals 1, 2, 3, 4, 5. So we have our two answers. And again, so a little bit more work here when it's in standard form. All right, so graphing does work, okay, but it's not proficient unless, like, if you come over to the next slide, right, and we have our graphing calculator, then it is pretty proficient. So if I just type in, f of x equals x squared minus 4x plus 2, and then g of x 7. Right? Now, when you have graphing calculator, solving by graphing is very, very easy. You can see my answers are -1 and 5, which match what we got. You take away a graphing calculator, and then solving by graphing is not the most convenient method, but it will always work. It's a great way to solve any type of equation, not just a quadratic. But you graph the left side of any equation, you graph the right side of the equation, and see where they cross. You could solve any equation out there. All right, so here, okay, it says solve by graphing. So I have these three problems. The graph of x minus 2 squared minus 4 is provided right here. You can see it has a vertex of 2, -4. A is 1 over 1, up 1 over 1, up 3. You can see that. And so if I want to solve when it's 0, okay, it's really asking me what are the x-intercepts. All right, so I look over here, okay, and I could draw a line at 0. Okay, and see that it crosses there twice and it intersects at 0 and 4. So my answers here would just be x equals 0 and x equals 4. All right, now it's the same graph, it's just equal to -4. So here, you draw a line at -4. Oops, bad line there, but you can see that it hits just at 1 point, and that's when x is 2. So now in this case, right, it only intersects once, so there's only one answer. In the first case, it intersected twice, so there's two answers. Okay, and now here C says when it equals -6. Well, that's way down here. It's not going to intersect at all. So what's that mean? Yeah, so that means that there are no real solutions. And I throw the word real in there because we're going to learn next week that there's something called imaginary solutions. So we say no real solutions. And then next week we'll learn how to solve that algebraically, and we'll get some imaginary solutions. Okay, so no real solutions. If the two graphs, the left side and the right side, never intersect, that means no solutions. So when you're solving a quadratic, you could have at most two solutions. Okay, you could have one solution if it goes through only the vertex, and then you could have no solutions if it doesn't touch at all. All right, and so that's a good example to show you all the different cases. All right. Okay, so right here, we're going to solve by graphing. So you could use technology here. Right here, if you just click on here, it's going to take you to Desmos, so you can type in the equation here. So on the left side, x minus 2 squared minus 1 equals 3. So if I type that in, f of x equals x minus 2 squared, I believe it was minus 1. And then I want to know, when does that equal 3? And so I draw a horizontal line at 3, and I can see that my answers are 0 and 4. All right. So now it's the same graph, but I want to know when it equals -1. So I come back over here, I change y to -1, and you can see that it only touches once. That's the vertex, so that's when x is 2. And then the last question says, when does it equal -4? So I come back here, make it -4, and you can see here that it never crosses. So here our answer would be no real solution. Okay. All right, here we want to simplify the radicals in the column and match it up with the corresponding equivalent by placing an X in there. So we want to simplify all these. All right, so when I simplify rad 8, right, that's 4 times 2. And so 4 times 2, if I put both of those in a square root, the square root of 4 is 2. So that's, I'm looking for 2 rad 2. And so that matches up with that one. All right, and so we just go through all these terms here and try to find, right, the largest perfect square that goes into these. All right, so 135 is 9 times 15. And so if I square root both of those, square root of 9 is 3. So this one will be 3 rad 15. Right? When there's a number already out in front, okay, all you're going to do is take, if it wasn't there, pretend like it wasn't there, simplify 50, then multiply the number out in front by 2. So 50 is 25 times 2. Square root both of those, and you get 5 rad 2. But since there was a 2 already out in front, that's now going to become 10 rad 2. All right, 24 is 4 times 6, so that's 2 rad 6. All right, so, and then you already had a 5 out in front, so 5 times 2 is 10, so this will be 10 rad 6. All right, 98, that's 49 times 2, and the square root of 49 is 7, so this one is 7 rad 2. 48 is 16 times 3, and so the square root of 16 is 4, so I'm looking for 4 rad 3. And then 125 is 25 times 5. So simplify that, and you get 5 rad 5. All right, simplifying radicals is very important. We want exact answers, and we don't want them rounded to decimals. And so we want to be able to simplify our radicals. So when we're doing the quadratic formula or solving by square roots, we can reduce our answer to the most simplified form. All right. Okay, so now this is a very important slide here. All right, so we're going to talk about solving by square roots and when it's possible to use this technique. All right, so looking at this first one, if I wanted to solve for x, there's only one x in this problem. So I just want to isolate that x. So I'm going to add 2 to both sides. And so now I have x plus 2 squared equals 50. And now I need to do the inverse of squaring, which is square rooting. So I'm going to square root both sides. And so on the left side, I just have x plus 2. Now pay attention, this is very important. When I square root 50, I want to simplify it, just like we did on the last slide. It's 25 times 2. So this simplifies to 5 rad 2. Right? But we have to put a plus or minus in front, because negative 5 rad 2 times negative 5 rad 2 is also rad 50. So we got to make sure that we put plus or minus. All right, so we come here, last step, subtract 2. So we get x equals negative 2 plus or minus 5 rad 2. And this is 2 different answers. It's negative 2 plus 5 rad 2, and then the second answer is negative 2 minus 5 rad 2. All right, so there's 2 different answers there, so that would intersect twice. All right, now we come over here and we look at this next one. Okay, can I use that same technique? I have a squared, so can I just square root both sides to get to solve? And so if we try that, so if we subtract the 2 from both sides, Now we have x squared minus 4x equals 9. So the x squared isn't by itself. So I cannot square root this yet. So if I add 4x to the other side, so I get x squared equals 4x plus 9. And now if I try square rooting it, it doesn't help because now I have an x on this side and that doesn't get the x by itself. So I'm kind of stuck right here. What do I do? All right, and so square roots, okay, solving with square roots only works, okay, when there's one x being squared. If there's an x squared, if there's a quadratic term and a linear term, then square roots will not work. We have to use a different technique. And so far, the only one that we learned so far is graphing. So you would graph the left side, you'd graph the right side and see where they would intersect. All right. So for right now, okay, take away from this slide is you can only use square roots, okay, if there's a single x that is being squared. Okay, if you have a quadratic term and a linear term, square roots is not a valid technique. We will learn some called factoring. We'll learn a quadratic formula. We'll learn completing the square. There are lots of ways to solve this, which we will learn in future lessons. Okay, so solving algebraically here, I got 3 problems here. I'm going to add 1 to both sides. Let me change my font size again. All right, so now I have x minus 2 squared equals 0. So when I square root both sides here, x minus 2 equals 0. There's no such thing as a plus or minus 0. So in this case, I'm only going to get one answer. And that is x equals 2. Right now with my mouse. All right, there we go. All right, so again, when you get 0 over here, there will not be 2 answers. You're only going to get one answer. All right, add 1. Now I get 4, so x minus 2 squared equals 4. Square root both sides. So the square root of 4 is plus or minus 2. So x minus 2 equals plus or minus 2. Add 2 to both sides. And so you could write it like this, but we don't. Okay, you could write it 2 plus or minus 2. But if you could actually do the addition, you do it. So you're going to get 2 answers here. 2 plus 2 is 4. And then you do 2 minus 2, which is 0. Yeah, so the answers, okay, the way you should write your answer is x equals 4, x equals 0. If this had a square root on it, we would leave it because you cannot combine them. But when they're integers, okay, we can combine them. And then finally over here, I'm going to add 1 to both sides. Get x minus 2 squared equals negative 5. All right, and then when I square root both sides, I get x minus 2 equals plus or minus square root of negative 5. The problem is you can't do that. Okay, there's never 2 numbers that the same number multiply up to a negative, because a negative times a negative is a positive, right? Positive times a positive is a positive. So there's no way for this to work. This is impossible. All right, so here we have no real solutions. All right, so again, whenever you're taking algebraically, all right, when do we get no real solutions? When there's a negative inside the radical. And graphically, we get no solutions when the 2 graphs don't intersect. And we'll check right here. Okay, solving algebraically here. So I'm going to subtract 4. Let me see if I can show my work. Get 16 right? Then I square root both sides. Square root of 16 is plus or minus 4. So when I subtract 2, 4 minus 2 is 2. Negative 4 minus 2 is negative 6. Okay, here I'm going to subtract 2. I get 98. Square root of 98, we just did on a previous slide, was 7 rad 2. Right, so you subtract 4, so it's negative 4 plus or minus 7 rad 2. Here I'm going to add 5, so I get 48. So we just did 48 on the other one. That's 16 times 3, so that's 4 rad 3. All right, so I'm going to add 2, and so I'll get 2 plus or minus 4 rad 3. Here, if I subtract 15, I get negative 2. When I square root negative 2, we can't do that, so we're going to get no real solutions. All right, and that's the lesson. So use this to help you with your lessons.